In this video, we are going to talk about the nomenclature of benzene containing compounds. Benzene over here, I've drawn a structure of benzene in showing all the carbon atoms and the hydrogen atoms in benzene, including the double and single bonds. This is basically the calculated structure of benzene. Now, the resonance hybrid, one of the resonance hybrids that I've drawn. Okay, now in this case, if I remove one of the hydrogen atoms, for example, from here, this hydrogen is removed and is substituted with some other functional group, for example, a halogen, let's say chlorine. So this compound now over here is a benzene derivative, and we can say that it contains benzene and is an aromatic compound. Okay, how are we gonna name these compounds? This in this compound over here, the one of the hydrogen atoms have been substituted with a halogen. So such a compound in which only one hydrogen atom has been replaced by another functional group is a mono-substituted derivative of benzene because only one hydrogen has been substituted. When so a single substituent when attached to benzene ring is this compound is called a mono-substituted derivative of benzene. These substituents can be of different types. They may be halogens. Whenever a halogen is a substituent, the name of that compound is gonna be halobenzene. This is how we name the halogen containing benzene compounds. For example, if I have chlorine as a substituent, it's gonna be named as chlorobenzene. If it were to be bromine over here, then it would have been named as bromobenzene, iodine, iodobenzene, and so on. Then methyl groups can also be the substituents over here. The CH3 group, the methyl group can be substituent. So in this case, it's gonna be named as methylbenzene. NO2 group can also be the substituent. NO2 group, whenever is the substituent, the compound is named as nitrobenzene. When the amine group is a substituent, it's then the story changes a bit. Then this benzene is no longer called benzene, but rather it's called phenyl. This entire benzene ring is referred to as phenyl, and the amine group stays as amine, so the name becomes phenylamine. What if we have two substituents, two identical substituents on benzene? Now in this case, we are gonna number the carbon atoms. Number any of the two carbons that contain the functional group as carbon 1. I have numbered this carbon as carbon 1 over here as shown in the red. So then start numbering the rest of the 6 carbon atoms in any order. You may go in the clockwise direction or the anti-clockwise direction because it's identical on both the sides. It's a symmetrical molecule along this axis over here. If I were to draw an imaginary axis over here, it's symmetrical above and below. Okay, so now I've gone in the anti-clockwise direction. Carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. Now I've named this as carbon 1, and the other carbon that contains the chlorine group is carbon 4. The name becomes 1, 4, 1, 4, showing both the positions of the two functional groups or the two substituents that are attached, dash, because we are to separate the numbers from the alphabets, and then after dash we are gonna use the prefix di because there are two chloro groups over here, dichloro, and then benzene stays as benzene. So 1, 4 dichlorobenzene. These are the two substituents which are attached to benzene ring. Similar will be the case if I were to change the position of the functional groups, if I were the substituents which are attached to the benzene ring. In this case, I've brought this chlorine atom to the carbon 2 position, carbon 2 over here. So it's gonna become 1, 2 dichlorobenzene. It's not gonna be 1, 6 dichlorobenzene, okay? Because in this case, The two sides from here to the first carbon and the other way around are not identical. They are not symmetrical, they are different. A general rule is that we need to keep this numbering, these two numbers, as small as possible. So if I were to go in the anti-clockwise direction, the numbering were to be in the anti-clockwise direction, then this second carbon would have been given a number of 6, which would have increased the number a lot. Like 1 comma 6 is a lot bigger than 1 comma 2. The 6 is bigger than 2. So we need to keep the numbering as small as possible. So I'm gonna go in the clockwise direction, and the numbering is gonna be 1 comma 2 dichloro, again because two chlorine atoms are there, and then benzene. Okay, now let's move forward. Okay, something very important over here. Benzene over here, if is attached to, if has a halogen as a substituent, a nitro group as a substituent, or a methyl group as a substituent, methyl, nitro, and halogens, they're gonna be named before benzene in the name of that compound, and benzene will stay as benzene. For example, the groups that we named over here above, the chloro came before benzene, the chloro came before benzene, the chloro was named before benzene in this entire name. The chloro group over here, the halogen is named before benzene, and benzene comes in the second part of the name. So if it's a halogen, it's going to be named as halobenzene, chlorobenzene, bromobenzene, iodobenzene, etc. If it has nitro as a substituent, then it's going to be named as nitrobenzene. Nitro group is NO2, and we've discussed it earlier as well. This is our benzene, and this is our NO2 group. So the name of this compound is going to be nitrobenzene, monosubstituted nitrobenzene. And if we have methyl group on the benzene ring, then it's going to be named as methylbenzene. This is our methylbenzene. Okay, so the name, this name comes before benzene in naming these compounds, which in naming the compounds that contain either of the three functional groups and benzene ring. Then if we talk about carboxylic acids or aldehydes, then benzene does not stay as benzene, but rather benzene changes, gets modified a bit, and the name of these functional groups come in the end. For example, over here, if I have carboxylic acid attached to benzene, the name becomes benzoic acid. Benzene, the benz comes before in the first name, and oic acid comes in the second part of the name. So benz comes in the first part of the name and oic acid comes in the second part of the name. So this is what I mean by before and after. Similar is the case with aldehydes. If we have aldehyde attached to benzene ring, then it's going to be named as benz, meaning benz for benzene, and aldehyde, benzaldehyde. It becomes the name of this compound. So if we have carboxylic acid or an aldehyde attached to benzene, then benzene comes, the benz of benzene, the benz, this part, benz, comes before, and oic acid of carboxylic acid or aldehyde of aldehydes comes in the second part of the name. This was important. Then when two different substituents are attached to benzene ring, basically two different substituents, meaning two different functional groups are attached to benzene, what we do in that case? The naming is done in order of preference. Order of preference meaning this is a series over here of different functional groups: carboxylic acid, OH group, methyl group, halogens, and nitro group. This arrow indicates that going down this series, the order of preference decreases. Carbon number 1 is the carbon that contains the root group. The root group is the one which is higher in preference.